What if I told you that you could, increase the performance of your web API, I don't know, twofold, threefold, fifthfold, I don't know, so many times, and you can make things blazing fast with just a few tricks. Or maybe they're not tricks, there's actually some good reasoning behind them. So this is the story of how we improve the performance of Platformatic DB a few times. And yeah, let's go into it. So I have created a very basic Platformatic DB application that is using a bunch of things. And as you can see here, you have the post, and you can try these out. So you have the gets, and you can try the get out. And the get is, as usual, empty because there's nothing. We can even store something here. So we store a movie. So let's store Star Wars, mostly because I'm watching a TV series now on Star Wars. Yeah, Ahsoka. And yeah, we stored this. Now, if I run the query again, we can get that value out. Okay, this is all baked by Postgres, which is absolutely amazing. So how can we make this fast? Let's do a very quick benchmark. So I can do my nice autocannon with 100 connection for 5 seconds. Okay, and let's go 3042 movies. And we just run it for 5 seconds on the live system, and it's running. And this gives us, I don't know, 5,000 requests per second as a median. So basically, this is what usually we get, with a very nice latency of 37 milliseconds, which is pretty amazing, to be honest. It's pretty good. I would not be, complaining too much. Like if we run this with htop, and you can see that is OBS recording, when we start running the load, you can see that it's the database. It's a full speed, and it's the one that's blackening. So let's run it again, and maybe for a little bit longer time. And as you can see now, you have Platformatic is very high, and the database is still eating all the things. It's the main bottleneck of my application. So you can see now that the database is 200, using all the CPUs possible, as well as OBS. So I don't have many things left. Anyway, I just wanted to show you what is happening at this point in time. Okay, so this is the status. Now, how can we improve this out? Like the question is, how can we improve this? Because it's still fast enough, but we can be faster, right? So what we can do is we can enable deduplication of everything. Oh yeah, this was released. So we got 2.0. Okay, and here we go. And here we can enable cache and set it to true. And this will deduplicate all the queries. So what does it mean? Well, we'll show you in a second. So now we have the system. If we go back to the other stuff, I said that it is restarted and reloaded. So now I can magically try to give it some test. And if we are running it, now it's 5 times faster. Look at it. 25,000 requests per second from the 5,000 we started with. Also, the latency halved, or even less. It's less than halved. Like this was the first one. It was 37 millisecond latency at the 99th percentile, and this is 15 millisecond. What have I done? Like literally, like what? How is this even possible? You flip a configuration and you just do the things. Oh, and it all works. What? Is this dark magic? Yeah, no, there's nothing that's but dark magic. In fact, David Copperfield will say that magic is just a lot of work and something we don't understand. So please, let's get into it. Okay. So you see, and we can even try harder. And I've not tried harder in a little bit of time. So let's try harder. And let's say for 20 seconds. And if we run htop, you can see that now it's my platformatic application that is clicking at 150%, and my database actually very low load. Why is that happening? Okay. Now you see we have moved the bottleneck from being the Postgres to being the our my application. I can even try to increase the load even further and trying to see if I can squeeze even more perf out of this. And in fact, maybe we can, because it goes to 180% of CPU for whatever reason. So maybe we can probably squeeze a little bit more out of it. We'll see. It's just dash p10 just does 10 pipelining request per 10 pipelining request. And in fact, we can. In fact, we can push it to 28,000 requests per second or something like that with 139 latency. Whoa. Yeah, this is amazing. Okay, so how does it work and why this is such an important thing to turn on in your platformatic application? And more importantly, how can you implement it yourself in your code base, which is, probably more important than all of this, or maybe you can just use platformatic DB, which is, something that useful. But okay, let's take a look. Okay, let's look a little bit of a presentation here. So we have, this is the typical representation of the Node.js event loop. You have your user and you have your user JavaScript and C++, and it executes. And it just, when it executes, that's the only thing that your process does. Okay. And this is for every single thread of your node runtime. Okay, so you have your thread, and your thread is executing code. Okay, then it schedules some asynchronous work, and then when that work is completed, you get an event in the event queue, and that is it's getting executed by the JavaScript runtime. So in other terms, if you want to see it linearized and not a circular thing, you have your Node.js application is essentially running when the event loop is not waiting for anything to happen. So you have your event loop waiting, and then you execute at some point there is an event, which means that you get some C++ to execute, which turn on, kick in some JavaScript, which then goes down and calls some event loop further. Okay, great. And waits for the event loop further. So this is amazing, but how does it matter? Well, when you're in our platformatic DB application, you have an HTTP request coming in, you do some synchronous processing, whatever. We compute the query to run, then we execute the database query on our database, and then and then there is a little bit of wait until we do that query, and then we send the response out. Also, this is where the connection pool kicks to the database matter, because this is limited by the database connection pool somehow. So when 3 requests comes in at the same time asking for the same thing, however, they are treated independently by Node. So what does this mean? It means that whenever you receive them, each one of them gets does their synchronous processing and their database query, and then and those are interleaved because of all the model that we saw before on the database. Okay. Now what happens is, and then we process them in return one after the other, which seems pretty normal, right? Like this is what you would expect. You do a request, you do a query on the database. Okay, but those 3 requests are asking the same data at the same time. So I'm asking the same query, I'm executing the same exact query at the same time against the same database. So why the heck I'm executing it 3 times from the same process? This is the question. So this is what that cache flag do, and we plan to ship more features on it, to be honest, in the future. But what that flag does, it deduplicates the request. So it takes 3 requests, of the 3 requests coming in the synchronous processing, it computes it generates the SQL query and compute an hash of that query and all the parameters. With that hash, we can now deduplicate the request, and essentially when that computation is done, just ship the computation out, which is phenomenal. And so we can just do one query to the database, essentially speeding up our system so many times and removing the bottleneck on the database. This actually, it's kind of a game changer for most applications, and it's something that I like a lot. So let's look at the module, okay? So the module is, I wrote it a long time ago to solve some problems for for GraphQL. So, but it's applicable everywhere, and this is kind of a little bit of a small a Swiss Army knife for caching, and you should be using this module. There is some other similar stuff that do very similar things. Basically, you create your cache. You can specify TTL, how long that data is available, and how long before you to return the data before that TTL has expired. So you can actually, do a query in the background. To be honest, in the platformatic DB implementation, we set both these to 0. We'll talk a little bit about further down, and that's it. And then you define your cache, and then you have your method, and then that's it. There's nothing else to do. This is it. Okay, this is the only thing that you need to do to get maximum perf out of this. Now you can track statistics, miss, error, how many times a function is deduplicated, so an execution is deduplicated, which is actually, all of these are important metrics to some extent, but they're not necessary. We can even store the data in Redis instead, which is phenomenal, because then you can even, keep it in cache and use stale, so you can even make this behavior scale a little bit better across multiple systems and reduce the load even further. You can transform the data, serialize, deserialize the key, the hash key. Seems pretty cool. So how is it used in platformatic DB? Well, let's take a look at that code, because it's pretty amazing to look at. So we can open SQL Mapper, and this is where it's implemented, and we have a cache.js file. And this is it. Like, this is what it does, and this is how simple to intercept all the HTTP, all the calls to our SQL Mapper tool that are used by our REST endpoints, and how to create a nice query that can compute a nice cache, okay? And a nice cache key, and that is fantastic, okay? So we set up the cache, and if we support a lot of environments, but we'll talk a little bit about what it supported, but internally, the cache is just created, and you can configure it with a lot of things, okay? Right now, we are setting the TTL to 0, which means we only deduplicate, okay? We only deduplicate. We do not store anything in Redis or something like that. And we will plan to add all the features, but for now, this is the only thing that works. We actually, in here, then we go and take our cache and define our function, a new function name, which serializes the data, takes our query, okay, which is composed by the query text plus the parameters, okay. We compute a new object without the context. Now, the context is actually very important, because this holds a bunch of data, but data is non-serializable. So you will have a hard time in doing anything here. So we need to do this trick. And yeah, it's just that. This generates us the caching logic. And then we need to add an entity hook, okay? And the entity hook is essentially a tool that we use to update the methods of our SQL Mapper, so that I replace find. So we get the original function, okay, and the query that we want to execute. And if we are in a transaction, we don't want anything cached, okay, of course, because it's on a transaction, so we want it to be part of that transaction. So we just keep going at the original. But if it's not part of a transaction, we can actually cache it. And what? We got 5 times better perf. So look, let's look at the numbers again, because I'm stunned. Like, we started with 5K. We started with 5K, okay, requests per second, and we finish at 25, 28 or something like that. Now, I want to try what happens with the system with without caching, and in yeah, if vim platformatic db. I want to try what happens with the system. Like, let's disable caching, and now let's run this with 20 seconds with 100 more or less requests per second being executed. Just want to see how it performs, okay? Because I think it will be way worse here. And look at how hard is being the Postgres machine is being hit. It's actually doing a lot of work. Okay. Also, my machine is pretty busy doing all the things right now. So, you know, take this number with a grain of salt and probably run yours. You might even be better. Now, look at it. Okay. This can take 5K easy. And the other one can take 28K. But very nicely, you can see that latency on this one without the cache is 400 milliseconds with 139 milliseconds with the one with the deduplication logic happening. So it's actually amazing, okay? Now, you know, it's... So who does not want 5 times more perf out of their APIs? Maybe no one. So maybe one day we'll turn it on by default. Anyway, we've just shipped this, so check it out, and see you in a few weeks. Bye.